There are several FAA flight information publications you will use during your flying career. These include the Aeronautical Information Manual, or AIM, Airport Facility Directories, and Notices to Airmen. The Aeronautical Information Manual provides basic flight information and ATC procedures for safe flight in the U.S. National Airspace System. The AIM contains the fundamentals required to fly in the United States and provides instructional and educational material. The AIM also contains items concerning medical factors, flight safety, and a glossary of terms used in the air traffic control system. The AIM is available by subscription and is updated approximately every 6 months. Another operational publication you will use is the Airport Facility Directory. This publication is issued in 7 volumes, with each volume covering a specific geographic area. The AFDs are designed as a pilot's operational manual containing all airports, seaplane bases, and heliports open to the public. Each volume is indexed alphabetically by state and city, and all pertinent information about an airport can be found in the AFD. This information includes communications data, navigational facilities, and special notices and procedures. This publication is also available through subscription and is issued every 56 days. During pre-flight planning, you will need to check the Notices to Airmen, called NOTAMs for short. These notices are considered essential to flight safety and contain information not known sufficiently in advance to publicize by other means. One type of NOTAM you will need to check is a NOTAM D. They are called D NOTAMs because they are transmitted distantly. The Aeronautical Information Manual describes D NOTAMs as containing time-critical information which may affect safety. This NOTAM is stored and is available until canceled and concerns changes relating to facilities or hazards that may exist. For example, information concerning an airport closure or navigational facilities which are not in operation may be given in a NOTAM D. NOTAM L is the second category of NOTAMs. L NOTAMs are circulated locally by voice or other means such as the telephone. This NOTAM is issued to satisfy local user requirements. Men and equipment crossing a runway or a taxiway that is closed may be classed as a NOTAM L. A NOTAM L will give information that is of a nice-to-know advisory nature. They are given to a pilot upon request before departure, while en route, or prior to landing. There are also FDC NOTAMs that are regulatory in nature. These are given system-wide dissemination and are issued to establish restrictions to flight or to amend charts. An example would be if an airport is permanently closed. NOTAMs, as well as other current information pertinent to a flight, are available from flight service stations. Before we look at the charts, a word of caution. Don't ever use out-of-date charts or publications because aeronautical data changes frequently. To be safe, check the effective dates and replace all out-of-date charts and publications. It's a good practice to throw away the old ones. Consult the aeronautical chart bulletins in the Airport Facility Directory and NOTAMs for any changes that may have occurred during the effective dates of a chart or publication. Some charts you'll become familiar with are the Low Altitude Planning Chart, World Aeronautical Charts, Sectionals, and VFR Terminal Area and Flyway Planning Charts. The IFR-VFR Low Altitude Planning Chart is useful for routing long cross-country trips in the United States. The eastern half of the U.S. is on one side, the western half on the other. It depicts airways, nav aids, airports, special use airspace, selected population areas, prominent bodies of water, and more. The scale is 1 inch equals 47 nautical miles. Jet navigation charts, produced by the Defense Mapping Agency, can also be used for pre-flight planning. The Jet Navigation Charts 43, 44, and 45 cover the 48 states and are scaled 27.43 nautical miles to the inch. Sectional and World Aeronautical Charts are relatively large-scale charts. A 582 nautical mile trip from Wichita, Kansas to New Orleans requires 5 sectional charts. World Aeronautical Charts are designed for navigation by moderate-speed aircraft. WAC charts are revised annually, with the exception of some Alaskan, Mexican, and Caribbean charts, which are revised every 2 years. The information shown on these charts includes airports and navigation aids, cities, principal roads, railroads, distinctive landmarks, and drainage. Hills and valleys, what is called relief, are shown by spot elevations, contours, and gradient tints. The scale used on World Aeronautical Charts is 1 inch equals 13.7 nautical miles, or 16 statute miles. Airspace is also shown on charts. Because of its importance, we'll be discussing airspace in a separate section later in this volume. Sectional charts are designed for visual navigation of slow and medium-speed aircraft. Each chart is named for a major city within the area of coverage. You should have little difficulty in reading these charts, since in many ways they are similar to automobile road maps. These charts use a scale of 1 inch equals 6.86 nautical miles, or 8 statute miles. We'll take a closer look at sectional charts in just a moment. VFR terminal area charts are similar to sectional charts in that they are designed for visual navigation of slow and medium-speed aircraft. As the name implies, these charts are used in congested terminal areas, since they provide greater detail and clarity of information. The scale is 1 inch equals 3.43 nautical miles, or 4 statute miles. Printed on the back of the terminal area chart is the VFR Flyway Planning Chart. It identifies flight paths clear of major controlled traffic flows. Some terminal area charts feature VFR waypoints marked with a 4-point star. VFR waypoints have a non-pronounceable 5-letter name beginning with VP, and their location is pre-programmed into most GPS navigators. Most VFR waypoints are co-located with visual checkpoints, marked with a magenta flag. Visual checkpoints can be used to identify your position to ATC. However, the 5-letter VFR waypoint identifier should not be used in communications with air traffic control. The sectional, VFR terminal area, and VFR flyway planning charts are revised every 6 months. The chart type most frequently used in private pilot training is the sectional. It's also the chart type used on the FAA private pilot written tests. The sectional chart name is shown at the top. Cincinnati in this example. Effective dates are found below the chart name. The names and coverage area of all sectional charts available for the United States are shown on the map. Cincinnati is shaded to show this is a Cincinnati sectional. The magenta boxes mark locations covered by a terminal area chart. Notice the north-south arrows at the top. Opening the chart in the direction of the north arrow shows the northern half of the area covered by the sectional chart. Looking at the other arrow, you'll see that the word south is printed upside down. When the chart is opened in this direction, it's upside down as well. Upon turning the chart upright, you'll find the southern half of the area covered by the sectional chart. Before we go any further, you must understand how the world is divided for navigation purposes. An imaginary line called the equator divides the world into 2 equal parts, the northern hemisphere and the southern hemisphere. From the equator to the North Pole is an angular distance of 90 degrees. At each 1 degree increment on this arc, there are imaginary lines running parallel to the equator. They are called parallels, or lines of latitude. These parallels of latitude are used to describe navigational positions on the Earth. The regulation writers like to call the lower 48 states the contiguous or conterminous states. To avoid confusion, we'll also use the language of the regulations. The conterminous 48 states lie between 25 degrees and 49 degrees north latitude. A position of 39 degrees north latitude would be located somewhere on a line 39 degrees north of and parallel to the equator. Lines of longitude, known as meridians, cross the equator at right 90-degree angles. Each meridian is drawn from the North Pole to the South Pole. These lines are used to determine positions east and west on the Earth. The starting point, 0 longitude, is called the prime meridian. By international agreement, this line passes through Greenwich, England. The prime meridian and the 180-degree longitude line have the Earth vertically. Longitudes on the eastern half are said to be east longitudes, and vice versa for the west. The lower 48 states lie between 67 and 125 degrees west longitude. A position of 77 degrees west longitude would be somewhere on a line 77 degrees west of the prime meridian. If we find a position of 39 degrees north latitude and 77 degrees west longitude, we'll locate Washington, D.C. From this example, you can see a specific position on the Earth's surface can be located by reference to its latitude and longitude. Traditionally, latitude is always given first, followed by longitude. On sectional charts, the degree lines of latitude and longitude are shown and are further subdivided by tick marks. Each tick mark equals 1 minute. There are 60 minutes in each degree. Let's use latitude and longitude to find Claremont County Airport on the Cincinnati sectional. Refer to the East Central Airport Facility Directory, and in the Ohio section, locate the information for the airport. It's located at 39 degrees, 4.70 minutes north latitude, and 84 degrees, 12.62 minutes west longitude. For practical purposes, you don't have to use the fractions of a minute to find the airport. Here is the 39th degree of latitude, and here is the 84th degree of longitude. The tick marks now come into use. Notice, to go north toward the 40th degree of latitude from the 39th degree of latitude, you count up. So, go north 4 minutes. Count up 4 tick marks on the 84th longitude line. Don't forget to count tick marks that are obscured by map features. To go west, move left 12 minutes, counting over 12 tick marks on the 39th degree of latitude. Where the lines intersect, you will find Claremont County Airport. Don't let the lines on which you count confuse you. As you can see, the way to measure distance between the 39th and 40th degree lines of latitude is by counting on a line of longitude. Since each minute of latitude is a nautical mile, by counting the tick marks on the longitude scale, you can measure distance. For example, you can determine the distance from Claremont County Airport to Lunken Airport by marking off the distance and measuring it against the tick marks of latitude on the longitude scale. It's 10 nautical miles. Measure it against the nautical scale on the bottom of the chart if you want to double check. The only place where 1 minute of longitude equals 1 nautical mile is at the equator. This is because lines of longitude converge as they go north or south. Even though the angular distance in degrees remains the same, the distance in miles decreases. Because of this, distance can only be measured using lines of latitude. Now that we've found Claremont County Airport, let's take a look at airport symbols. On the sectional chart legend, you'll see a number of airport symbols. These are hard-surfaced runways greater than 8,069 feet. These symbols indicate runways 1,500 to 8,069 feet in length. This anchor indicates a seaplane base, and circles alone designate airports with other than hard-surfaced runways. An R inside a circle indicates a private airport with non-public use, but having emergency or landmark value. Airports with control towers are shown in blue, along with their related information. All other airports and related information are shown in magenta. Now that you're familiar with some basic airport symbols, let's now see what we can find out about Clermont County Airport. A magenta circle indicates a hard-surfaced runway, while the open space within the circle shows the approximate runway orientation. The runway is between 1,500 to 8,069 feet in length, and the airport has no control tower. We can find the actual length of Clermont County's runway by looking at the coded data provided along with the airport name. An airport's longest runway is always shown here in hundreds of feet. Clermont County's runway is 3,700 feet. Clermont County uses a standard left-hand traffic pattern. If a right-hand traffic pattern is designated for a runway, the letters RP followed by the runway number show this. Let's take a look at an airport with multiple runways. At Cincinnati Lunken Airport, the longest runway is 6,100 feet. The L with a star means that there are runway lights which are either pilot-controlled, part-time, or available on request. An L without a star means the runway lights are left on from sunset to sunrise. The elevation of Lunken Airport is measured at the highest point on the usable portion of the landing area. The tower frequency is 118.7. A star following the tower frequency indicates a tower which operates part-time. Hours of tower operation can be found in the sectional chart legend or in the airport facility directory. Tick marks around the basic airport symbol indicate that fuel is available and the airport is attended during normal working hours. The star at the top of the circle indicates an airport rotating beacon. This rotating beacon is in operation from sunset to sunrise and uses alternate white and green flashes. A great deal of attention is given to showing the Earth's surface elevation and obstruction data on aeronautical charts. Contour lines are lines connecting points on the Earth of equal elevation above mean sea level. On sectional charts, basic contour lines are spaced at 500-foot intervals. Intermediate contour lines may also be shown in moderately level or gently rolling areas. The pattern of these lines and their spacing will give you a visual concept of the terrain. Widely spaced contours represent gentle slopes, while closely spaced contours represent steep slopes. Color tints are used to show bands of elevation. These colors range from light green for the lower elevations to brown for the higher elevations. Generally, obstruction symbols are used to show man-made vertical features that extend more than 200 feet above the ground. Examples of features considered to be obstacles to low-level flight are antennas, smokestacks, towers, and elevated cables or pipelines crossing rivers or valleys. This symbol is used to show obstacles less than 999 feet above ground level. And this symbol is used to show obstacles 1,000 feet or more above ground level. When known, the elevation of the top of the obstacle above sea level is shown. Additionally, the height above ground level is shown in parentheses, just below the elevation. Groups of obstacles are shown using this symbol. Obstacles under construction are indicated by the letters UC next to the symbol. Strobe-lighted obstruction symbols are shown as this. Maximum elevation figures are shown on the chart in quadrangles, bounded by ticked lines of longitude and latitude, and are represented in thousands and hundreds of feet above mean sea level. The maximum elevation figures are based on information available concerning the highest known feature in each quadrangle. Now we'll draw a line from Clermont County Airport to the Fayette County Airport, over to the Richmond Airport, and then back to Clermont County. Let's take a look at some of the symbols along this route. Departing on course from Clermont County, runway 4 would take you right over a major highway and an obstruction that is below 1,000 feet AGL. Next, you'll cross over a road and the small town of Owensville with a racetrack on the left. A power line with lakes on the right and left is next. Cross the power line, road, railroad, and you'll reach the small town of Martinsville. Airborne Air Park is now off to the left. The town of Sabina is on the left with a major road that leads right to Washington Courthouse. Fayette County Airport is just northeast of the town of Washington Courthouse. Departing Fayette County Airport for Richmond Airport, we will cross a railroad, road, and then Interstate 71 as indicated by the shield shown here. Another 4-lane road, railroad, and Xenia Airport are next passed. Notice the magenta flag at the town of Xenia, denoting a visual checkpoint you can use to advise ATC on your initial contact of your position if necessary. Note the bold 17 shown here. This is the maximum elevation figure, or MEF, for the highest known feature, expressed in feet above sea level for the quadrangle bounded by these ticked lines of latitude and longitude. Back on course, cross over a 4-lane highway, 2 groups of obstructions, and another 4-lane highway, and you see Moraine Air Park. 2 restricted or private airports, shown for their emergency and landmark value, are next. They're followed by an obstruction and a city with a racetrack. Another obstruction and a road lead to Richmond Airport, which has the symbol for parachuting activity. Departing Richmond Airport for Clermont County, there is a road off to the right and roughly parallel to the course that goes over to Hamilton Fairfield Airport. About halfway to Hamilton Fairfield Airport, a lake with a dam is shown. Just south of Somerville, a lighted obstruction 1,903 feet above mean sea level and 1,003 feet above the ground is depicted. Cross Blue Ash Airport, shown with a magenta flag denoting a visual checkpoint, then cross a 4-lane highway, an obstruction, one last 4-lane highway, and here's Clermont County Airport. As you can see from this short trip, reading the symbols on the sectional chart is not difficult. Every day, the Earth turns one revolution of 360 degrees. Since one revolution is completed every 24 hours, the Earth revolves at 15 degrees per hour. Just as distance is measured in degrees east or west starting at the prime meridian in Greenwich, England, Greenwich is also used as the starting point in time calculations. In most nations, the practice is to establish a time zone for each 15 degrees of longitude, making a difference of 1 hour between each time zone. The conterminous United States is geographically located approximately between the 67th degree and the 125th degree of longitude. Since each 15 degrees of longitude equals 1 hour, the lower 48 states have 4 time zones: Eastern, Central, Mountain, and Pacific. For example, when the sun is directly above the 90th degree of longitude, it is noon Central Standard Time. At the same time, it's 1 p.m. Eastern Standard Time, 11 a.m. Mountain Standard Time, and 10 a.m. Pacific Standard Time. Aviation uses a 24-hour clock to avoid mistakes which could occur from failure to specify a.m. or p.m. You might have heard of the 24-hour clock being referred to as military time. Basically, it works like this. The PM times simply continue to count up after 12 o'clock, with 1 o'clock PM being 1300. 2 o'clock is 1400. 3 o'clock is 1500. You would refer to 3:30 p.m. as 1530, and so on, up to 12 o'clock a.m., which is 0000. 1 o'clock a.m. is 0100, 2 o'clock is 0200, and so on. The old term, Greenwich Mean Time, has been replaced with the term Coordinated Universal Time, or UTC. You will also hear UTC referred to as Zulu time. So if you wish to convert from local time here in the U.S. to Coordinated Universal Time, or Zulu time, you add hours as shown in this table. For an example, if you depart at 10:30 Central Standard Time for a 2-hour flight to an airport in the Mountain Standard Time Zone, what will the time be when you land? The first step to find your landing time would be to convert from Central to Coordinated Universal Time. Looking at the time conversion table, you would need to add 6 hours. This gives you UTC, or Zulu time. Factor in your 2 hours for flight time, and you'll see that your arrival time will be 1830 UTC, or Zulu. The last step would then be to convert back from UTC to local Mountain Standard Time. Remember, to convert from UTC to local time, you subtract. In this case, 7 is subtracted. This gives an arrival time of 11:30 Mountain Standard Time. Like everything else in aviation speak, the more you do it, the easier it becomes. You can probably expect a question or two on the written portion of your test on time conversions. But if you remember what we've just discussed, they'll be easy.